let's start explaining this. Air ducts. So we can have exposed ducts like this one, or we can have hidden ducts. So this probably it's something that will be hidden because it doesn't look very nice. So that is the diffuser, and there will be a false ceiling hiding all these ductwork. Okay. And this is what I mean. So you see, well, I don't know if you see this. You see that here we have a conflict. We have a duct going in this direction, and then we have another duct going in this direction. We cannot go through the duct. So this one does this thing. Okay, so you see that here we go down, and probably we will go up again. So those are the kind of things that when we are facing the supply and the return, these are the kind of things that we have to do. But it depends, again, there are unlimited layouts that we can do, and we eventually will have a conflict between the supply and the return. So we have to solve it wherever it happens. And then the problem with this is that we need to increase the height or the width of between the false ceiling and the structural element and the slab, and that means that we need a higher building, and that means that we have to build more volume, and building more volume means that we have to spend more money. Okay, so if we try to prevent all these conflicts, we will save space, and saving space, it's saving money, because the height of sometimes if we have a requirement, if we have a limit of the building height, if you keep adding, or if you keep adding different ducts at different layers and making the space between the false ceiling and the slab bigger, there is a moment in which, okay, so you can build the third floor because you have exceeded the height limit in the municipality or in this area, so you cannot go higher, or your building should be within these limits. If you keep adding space in the false ceiling, you are losing, probably you will lose one floor. If you lose a floor in a hotel or in an apartment building, that means that your client will lose a lot of money because you have designed a bad duct work. So it matters. Okay, so we have to fix these things, and we have to prevent these conflicts. And then if they happen, we have to minimize them, because if we have 30 or 40 conflicts in our duct work, it will be worse than if we have only 2 or 3. So eventually there will be a few conflicts, but we have to minimize the amount of intersections between supply and return. That's the theory. So the theory, yes, avoid intersections. How can we do it? Well, this is what we're going to try to solve today. This is, I told you that this 20 CFM, it's like the magic number. Okay. Well, it's 20 because this is taken from ARCH370. ARCH370 is the standard that we use in the United States. And well, look at this. This is the CFM per person that we need, depending on the kind of building that we are doing. In a bar, a cocktail lounge, we have 30 per person. Well, bar, closed space, a lot of people drinking, sweating, dancing, whatever. We need more, probably we need more than 20. In a dining room, fast food, well, we can have 20. And in the kitchen, we have 15. Okay, so these are the minimum values. So that means that if the requirement is 15 and you use 20, we are fine. If we are in this special space, we need 30. So what are the special spaces? When do we have more than 20? In gambling casinos, yeah, a lot of excitement there. Office spaces is 20, reception areas is 15. So if we always use 20, that's good. Smoking lounge, it's 60. Public restrooms, it's 50. Okay, so yes, if we are designing something special, we have to increase the ventilation and the airflow. But other than that, it's 2015, 2015. Operating rooms. Okay, in hospitals, I told you that it's something, but other than that, 20, it's something that it can be either 20 or 15. If we only remember 20, because that's the minimum number. So that's fine. Okay. And in a bar with a lot of people, in smoking rooms, in operating theaters or operating rooms in hospitals, public restrooms. Okay, so there are special spaces, and probably we need more airflow. But 20 goes well in classrooms, office spaces, lobbies. So usually 20 goes well with everything. We have always CFM, and we have liters per second per person. Okay, so in the international units, we use liters per second or liters, and that's another thing. We have CFM per square feet per unit area. So sometimes we have this requirement. We have 0.35 CFM per square feet. Then we have to multiply times the area of the room, and then we get the value. But again, if you use 20 CFM, usually it works for 90% of the buildings. So that's what we are using, 20. Then what's the formula? Well, it's very simple. The area of the duct is the airflow divided by the velocity or the speed. Okay, so we have the airflow. It depends, it's 20 CFM times the number of people. That's the airflow. We divide it by the velocity, and then we get the area. This is the right formula in international units. Imperial units, we have this bloody conversion, and we have to add this 154. Why is that 154? Because the airflow, it's cubic feet per minute. Okay, and this airflow, it's not in volume. We have to turn this into mass, into pounds. So we know that the air density, it's 0.0765, I think, pounds per square feet. Okay, we have to do this conversion because this airflow, it's not in CFM, it's not in volume divided by time. It's in and probably now we have like 60 times 60 minutes per hour. Okay, so we have all these conversions, so that's why we have this 144. Okay. So in international units, it's that simple because we have cubic meters per second. Then cubic meter, it's the air density is 1. It's something very easy to remember, and we don't have these conversions. Here we have minutes. Probably we have to turn minutes into seconds or hours. Then we have to turn the air density in cubic feet. We have to turn it into pounds. So that's why we have all these things, and we end up having this 144. Okay, so that's the formula. The area of the duct is 144 times the Q in CFM, cubic feet per minute, divided by the velocity. And the velocity is, to be consistent, it has to be in what's the unit of the velocity is space divided by time. Space is feet, time is minute. Okay, so probably this velocity is in feet per minute. In the international units, it's meter per second. So this is feet, the unit of space or length, divided by the unit of time, minute. And that's it. Okay, so we have meters per second in international unit, feet per minute here. And the airflow rate, it's cubic feet per minute. This is what CFM stands for. And okay, and another thing, this area, it's in inches square. Okay, so when we convert feet to inches, cubic feet to pounds, hours, and whatever, so we end up having this number 144. So that's why we have this 144. So the cross-sectional area is inch square. Then we can have a square or we can have a circle. And but that's the area. So it's not the dimensions itself. It's the area what we have to fix. So that is an example. Imagine that we have 6,000 CFM. If the velocity is 1,200 feet per minute, the area is 720 inch square. So it would have a 26 by 26 square. We have this area. We had to do this manually, but now we have Revit. Okay, so in Revit, we just have we can change the size, and then we can change the speed, or we can test, or we can check the velocity. And these are the ranges. Okay, so this table is what we have to know. This is feet per minute. So that's the type of duct, main duct, branch, main branch. So I will explain this. And this is the units, meters per second, international system. And this is in feet per minute, the imperial system. We have 3 different categories: comfort system, industrial systems, and high-speed systems. Well, high-speed systems, it's not for buildings. Okay, so this is for cars or planes or whatever. So we are not dealing with that. Industrial system, it's in industry. So again, we're not designing industrial buildings, factories, they have another standard, they have other requirements. So we are designing comfort systems, buildings, single family houses, commercial buildings. So we are just dealing with this column, and we're not dealing with international units, we're dealing with this. Okay, so those are the limits to our ductwork. So what is a branch duct? Well, this one is the one that we have in the room. So this would be the branch duct. Okay, so the lowest velocity has to be inside in ducts inside the rooms. The main duct is the duct that it's connected to it's usually outdoors, and it's connected to the air handling unit. So this main duct can be the duct that is connected to the air handling unit and goes through the shaft. And then the main branch duct can be the one that goes through the hallway. Okay, so that's it. The first, the ducts connected to the air handling unit and going through the shaft, the maximum velocity has to be 1,300. Well, it can be between 800 and 1,300. Then, if we have a branch in the hallway, it can go from 600 to 900, something like that. And then, if we have those ducts in the room, then we need the maximum is around 500 or 600. Okay, so there's a range. Okay, so it doesn't mean that it has to be 255. No, it can be between 200 and 500. But this is what we have to check now with our with Revit. Okay, so in Revit, how does it work? We create the duct, we assign a diameter. By default, I think we have 20. We have the airflow. We know the airflow because we know the number of people that we have in the room. And then we check the velocity. If the velocity, if we have a duct inside the room and the velocity is between 200 and 500, that's good. If we want to make the duct thinner or smaller, we will increase the velocity. We can do that up to 590. So if it's close to 200, the duct will be bigger. If it's close to 500, the duct will be smaller. So usually we want smaller ducts. So the speed is, so the air moves faster. If the air moves faster, we end up listening to the flow. But look at this room. When it comes to the acoustics, what is the most annoying noise that you hear other than my voice? Projector. Probably the projector. Okay. And I think it doesn't mean that if we turn off the projector, I'm not going to do it. Probably the second most annoying thing would be the airflow, the supply air. But if the projector is worse, what's the point of maximizing or minimizing the speed so that we don't listen to that if we are going to have a projector? This shouldn't happen. Okay, so if we stop talking and we listen to this and we are aware that there's a noise, there's something wrong, okay, with this projector. But the projector noise, it's the volume. We have we have the highest volume, and probably we don't listen to that. But if we turned off this projector, probably we would listen something here. Anyway, there are acceptable limits. Background noise. We will study this. We will try to introduce acoustics in this course. But yeah, so those are the kind of things that we take for granted, but we shouldn't. Anyway, those are the limits, and we have to work with the Revit file, and we have to check the velocities to see if those limits are acceptable or not. So what are we going to do? We have to compute the air volume in every room and branch. So the air volume or the airflow, we have 30 people times 20, it's 600. We have 2 diffusers, it's 300. This is what we did last time. Now we're not just going to use a 20-inch round duct. Now we will check the right velocity of those ducts. Why can't you use the same file that you used before? Okay, so if I have to change the size, I'll do it. And well, because changing the size, you have to go duct by duct, changing the size. And then all the fittings, you have to select all the fittings and change the size as well. So it will be, I think it will take longer than start from scratch. So we are going to start from scratch. We're going to do it again, because the goal here is to practice. So we have to do this time and time again. So we're not fixing what we did last time. We are starting from scratch. And then we have to, well, we have to check the velocity, and this is what we are going to do now. And then there's another thing. It's the pressure loss. Okay, so this is the origin of the system. So that would be the air handling unit. In the air handling unit, we have a fan, and we have to move the air. We have to move that flow, and we have to move that flow at that speed. And then we have different branches with different diffusers. You see that here we have different diffusers. How can I make sure that every diffuser has the right airflow? Because we are connecting everything together. So the airflow through those diffusers has to be 300. The airflow in the office space, I think it was 80. How can I do that? Well, this is very important. Those elements here, those are dams, okay? I think we all have experience when we live in a house with different rooms, with different bathrooms, or when we are taking a shower in a gym or whatever. So we are there happy under the warm water, and someone opens the hot water somewhere else, and suddenly the water, it's cold. Have you experienced that? Is it annoying? Well, it's very easy to fix it, and this is what happens. So this is the source of hot water or air, whatever. So if all these pipes or ducts are wide open, so the water, what does it do? It goes to the east equator, and east equator is what. So if I'm water, why do I have to go up until the end of this if I can go here? So this is what happens. So we should have like different valves or different, and this is what we have in water circuits and in air circuits. So we have to fix it. Designing the circuit is not just something that we do in Revit. When we have all the ductwork here, we have to run the system, and the engineers, they have to make sure fixing this or changing the airflow in each branch. They have to make sure that each duct or each diffuser has the right flow. Okay, so it's not just designing it. Before giving the owner the keys to the building, someone has to check this, and they have to check the hydraulic circuits, the hot water, the heating, whatever, and they have to check the air ducts. It's not just, okay, I have made all my calculations and everything is correct. It's correct, but now you have to adjust all these valves so that, and people usually they don't do it. So that's why you spend thousands or millions of dollars in these mechanical systems. The mechanical system is good. It's the best mechanical system available in the market. The engineers, they have done a good job. They have calculated everything correctly, but someone has not tested the system before delivering the building. And that's annoying because as users, we don't know how to do this. So it's the company who the one or the responsible to do this. Okay, so and it takes time because you have to check all the systems, you have to check all the airflow, you have to make sure that and you have to measure the airflow, their equipment to do that. But yeah, probably because it takes time and people doesn't know anything about it, and we all take for granted that when we are having a warm shower, if someone opens another bathroom, we will have cold water. We take it for granted. It's like unavoidable, like the law of gravity. Well, it's not. It's just checking the circuit and working with these valves and making sure that each tap or each diffuser has the right water flow or airflow. Okay, so next week on Tuesday, we will do this. Okay, so I want you to calculate this by hand, but today we're going to use Revit, and so let's do it. So that's all we need to know about ducts. And then we have the other lesson is about it's about aesthetics. What can we do? So we don't have to think that air ducts are something that have to be hidden. It's actually cool. Okay, so if you have the loft or an apartment like this, people, oh, it's cool. I have the air ducts here. So when we expose the air ducts, they are usually round, and the finish, it's something like galvanized steel, aluminum. It's painted, probably it's something metallic. I don't know if it's aluminum or probably aluminum, and it's painted, but we can have the original aluminum color. Or especially in malls, in great commercial buildings, we have everything's exposed, the structure, so we don't have any false ceiling. And this is cool. Okay, look at this. This doesn't have diffusers. So those are, as the air flows, it's like a balloon. We inflate those ducts. Okay, so they are not solid elements. They are made of cloth. So when we blow, it inflates. And you see that it doesn't, we don't have a diffuser. We have small perforations here, and the air is flowing through this branch. Okay, so there are different ways to design this. We can have the ducts exposed, or this is the typical hidden duct. You see that there's a false ceiling here, and we are hiding all these ducts. But that's the real stuff, okay? So when we have a T, this is a T, and there's a guy fixing, connecting things, sealing. So the more difficult is the ductwork, the more time it will take to do all these fittings, and the more the company will charge the client. So our goal is to minimize conflicts, to minimize the fittings, and to make the ductwork as easy as possible. So that's it. Okay, so we can have exposed ducts, we can have hidden ducts. Usually when they are hidden, they are rectangular and they are wrapped with insulation. When they are exposed, they are round because it's nicer. Okay. Anyway, that's the real stuff. But think about this guy. Okay, so this poor guy, probably they make more money than I do. But it takes a lot of time, it takes a lot of effort, and the easier we make his life, the less time this guy will be there, and the less money they will charge our clients. Okay, so let's open the building template. I'm afraid of using Revit 24 because last time we used Revit 23. Let's be brave and let's use Revit 24 in systems. I think it hasn't changed that much.
They keep up with the times.
What?
We gotta keep up with the times.
Yes. Yeah, we have to do it. So we're not cowards. We have,
Right.
Yeah. So, and giving up is not an option. So let's use Revit 24, and I hope that everything. I have tried Revit 24 before, and I haven't seen any difference between Revit 24 and 23. That's the building. We know the building. We are in a mechanical template. So if we are in a mechanical template or a mechanical discipline, so you see that here we have the discipline. Make sure it's mechanic. I think on level 15, we have to change the discipline from architectural to mechanical. And on level 30, we have the mechanical discipline, and level negative 15, we have the mechanical discipline. So we are on level 0, level 30. Okay, so on level 30, we have the roof. We know what to do. We have to go to systems. We have to select the mechanical equipment. The first thing is the air handling unit. So we will select the air handling unit, the first one. I think we selected the second. Okay, we are going to select the second one. Now we have to place the air handling unit by pressing the space bar. We can place the air handling unit. So I'm going to place it like here, facing the shaft. Okay. And every time we do something, let's check that it's in the right place. Okay. So remember, what we have to do first is to change this because this is 30 by 30. 30 by 30 is too much. So let's edit type. And the supply air outlet, I'm going to type 20 by 20. And the return air inlet, I'm going to do it at 20 by 22. Uh, 20 by. Okay, let's type 20 in all of them because and apply. So you see that we have changed this one too. Well, in some of you asked me about the return, what we have to connect to the return ducts. In this air handling unit, you see that we have in here and we have another inlet there. Well, we need to know the Revit code. So this is the out. So this is the supply. If we have a duct that goes out, this is the supply duct. And then we have two inlets. One of them is for the return, and the other one it's for the exterior air inlet. Okay, because here we have the heat recovery, and we mix the return and the air and the fresh outdoor air. Well, in this case, if we look at this symbol, that means that this is the one that we have to connect to the return ducts. So we have return diffusers, return ducts, and then we have to connect with this on the top because we have this symbol here. This symbol is different. So when we have an inlet, but with this symbol, that means that it's the air, outdoor air inlet. But this is the return inlet. Okay, so probably if you connect the return ductwork to this one, you won't get the right CFM at the end of this. So, but it depends on the air handling unit. If you download another family from somewhere else, it might be different. So that's why we have to know what materials or what families are working with. Anyway, this is out. There is only one out. So it's clear that this is the supply. So we draw that. rectangular, let's draw the default round. We go to the shaft, and if we go down, we have to click, and now we have to go downwards. We have to change the elevation. So this middle elevation, let's type negative whatever, negative 50, a lot. And then we make sure that we are going down. And this is not enough. We have to keep moving, and then we have to click, and the vertical duct, or the vertical duct appears there. Okay. Now, this is not the end of, so we can delete this, and but that's the supply. Now, let's work with level 0. So on level 0, we are going to place supply diffusers, return diffusers. And so we are going to work with the supply and the return on the first floor, and then we will copy everything to the second floor. I think that's the right way to do it. So supply diffusers, air terminal. By default, we have return. So select supply. I think it was 12 by 12, 8 neck. So that's this is what we have to do. Okay. So we can have a supply here, a supply there. What do we have to check? The airflow. It has to be 300. We explained that last week, why it is 300. It's because of the people. We have 30 people times 20, it's 600. We have 2 diffusers, it's 300 each. And what's next? Yep.
So is that the 6-inch neck or the 8-inch?
8. Doesn't matter, but I think I'm using 8. What? Now, if we look at the 3D view, they are on the floor. Okay, by default, we place the diffuser and it's on the floor. We have to change that elevation up to. If this is 15, again, the minimum distance from the floor to anything, it's 10. So I think we used 11 last time. So change the elevation to 11 feet. And now they are in the right position. Okay. So again, it's not intuitive. So placing the diffuser, if we don't change to the 3D view, we are creating all the ductwork on the floor, and it has to be close to the ceiling. So be careful with that. So now, what's next? If we are on the here, we have to work with ducts. So we can create a duct. By default, I think we use the 20-inch diameter. Let's do this, and then we will change it. So we can stay here. And what the hell is happening? Why don't we see the duct? Because it's there. Because Revit has decided in my computer that the duct is here. Why? We are on level 0, but the mid elevation is 40. So it's way up. What's the mid elevation? If the diffuser is 11, the duct has to be slightly above. So the elevation should be 12. And now I hope that we will see the duct here.
You make the lower elevation 12, is that what you do?
The mid elevation. Okay. So we are here, and now the easiest part, we have to connect this to this. Click, right click, flex duct, and connect it here, and it works. Okay. Now, this is what we did last week. Now we have to check the velocity. So what is this? We are inside the room. So it's a branch duct. So the velocity should be between 200 and 500. So let's click on this duct, and we have a lot of information here. You see that we have the airflow. The airflow, it's 300 because it's connected to the diffuser, so that's correct. And then we have the velocity. The velocity is 130.
And when I put my duct,
If I check the velocity, it's 137. If I go to the table, the velocity should be between 200 and 500 or 590. So if the velocity is 100, do I have to make it bigger or smaller?
well,
Smaller. Okay. How much? Let's try, instead of 20, let's try 12. And now check the velocity again. It's 380. Perfect, because 380 is between 200 and 500. Okay, so can we make it even smaller? Can I make it 10? No, because, well, the velocity is 550. So it could be 10 because it's below 590. I prefer 12. Okay. And why are we using even numbers? I don't know, but well, in every single ductwork that I have designed, I don't know that the company always asked me to use even numbers, not odd numbers. So 9 inches, 11 inches, 13 inches is not an option. So we use 8, 10, 12, 20. At least in Europe, I don't know here, but I'm used to working with even numbers. I mean, in theory, there is no, you can use 11, 9, or whatever, but I have had these experiences and I have always been using this kind of even numbers. Okay. Good. Now we have to insert a new one. We are on level 0, and then we have to right click here, draw duct, draw flex duct, flex. Now we click and well, it always happens. Again, this is Revit making decisions. It decides that it has to go up this T. No, I delete it. And I rotate the T, rotate again, the other way around. There you go. Okay, but at least the T is there. And now from the 3D view, I can, with the flex duct, I can do this. And now it works well. Okay. Check everything again. Let's check this duct. The airflow is 600. That's good because we have connected two diffusers to this, 300 each. So it's and what about the velocity? The velocity is 700. 700. It's above 590. So this duct has to be bigger. So I'm going to make it 14 inches. And now the velocity is 560. You see? Okay, so this is what really happens. We try to use the smallest diameter, but at some point we have to increase diameter because it's not enough. Okay, so Revit creates the reduction. Then after the reduction, it creates a T. So Revit does a lot of great things. Okay, sometimes it gets on my nerves, but most of the things are correct, the decisions that Revit makes. Okay, and then we have to go to the hallway. And before doing this all the way to the hallway, I'm going to create the return ductwork on the same floor plan. Okay. So let's go to air terminal. Now we have to select the return diffuser. The only return diffuser is 24 by 24 and 12 by 12 connection. Probably I could have inserted a new one. Let's try. Insert family. We are in mechanical MEP air side components. Air side means we are dealing with air, so we have to go to air side components. And do we have air terminals? And here we have exhaust return diffuser. So let's, I did it too. So it's in return diffuser. We have return diffuser hosted. That means that it's inserted in the false ceiling. We're not using that. We have a return diffuser with plenum. Probably this is a return diffuser with plenum, this one. So in the second part of the course, we will analyze this building and we will create the ductwork of this building. So probably we'll have to use this. Let's use this return diffuser and see what happens. Open, overwrite existing version. And let's look at the options that we have. Okay, so that's the only return diffuser that Revit has, this 24 by 24 and 12. In supply diffusers, we have more options, but that's the return diffuser that we have. So let's place it here and there. Why am I doing this? I know, for the sake of symmetry, I'm lining up the return and supply diffusers. And the only thing is that they have to be as far as possible. Okay, so if the supply diffusers are here, the return diffusers should be on the other side of the room. You see that there's a difference, and this is the explanation. You see what a return diffuser is? A return diffuser is something that has arrows going towards the diffuser. So that means that it's collecting the air inside the building. And you see that this square with this diagonal line here is the same thing that we had in this. You see that the symbol is the same. So that's why we have to connect return diffusers to this symbol, because this symbol is different. Okay. So return diffusers. Now, what's the airflow? The airflow has to be 300 and 300. And we have to change the elevation. The elevation by default is 0. We have the same elevation, 11 and 11. Okay, so make sure that before moving to another room, make sure that everything works well. Look at the 3D view. Let's see that the diffusers are at the same level. If you don't like these two kinds of diffuser, we can always edit type. And you see that the duct width, it's 12. And the diffuser width, it's 2 feet. We can change that. Imagine that this is 1 foot by 1 foot, and the duct width, it was 8 by 8. If we apply, I hope it works. Okay. Wrong. If I edit type, I have to duplicate because I need another name for that. So first, duplicate. And this is a 12 by 12 face, 8 by 8 connection. And now I can change that. The duct width is 8, 8. The diffuser width is 1 and 1. Apply and OK. And now if I select this one and I click here, I should have 2 diffusers. I have the 24 by 24 and the 12 by 12. That makes more sense. What's next? Have we checked the elevation? Yes, we checked the elevation. And next, we need the duct. So let's go to the systems, duct. If we have the same airflow, we are not going to start with, well, this diameter is 8 by default in the, why is that? I don't know. But we know that this is 12, okay? So we can start with a 12-inch diameter because we know that that goes well with the So now I do this. And now this is extremely important. Okay, so now we have to pay attention to this. If we select this duct, the supply, what do we have here? System, supply, air. If we select this one, what is this? Supply air. We can't connect a return diffuser to a supply air duct. So we have to change this to return air. And now it will work. If you're working on level 15, here we have colors. So with colors, we know what supply and what return is. So that's why working with colors, it's useful. But here, for the sake of bravery, we are working without colors, okay? But we can find out if we are working with supply or return air diffuse or ducts. So now we have to check the elevation of this bloody duct. So Revit decides that the elevation is not 12, it's 11, 2 inches, whatever. So it's making 12. Okay, so now the elevation of the two ducts, that makes sense. I mean, if we are sensitive human beings, we are sensitive to this kind of, if these two ducts are at different elevation, it's like, why is that? So it creates like a uneasiness that it doesn't make sense. Okay, so if we can make things that are lined up, if the elevation of different of the same things is the same, that works well for human beings. So now we only have to draw a flex duct here. I can draw another flex duct here. I have to change this T, delete, rotate the T. I always select the wrong direction. And now flex duct, connecting this, there you go. And let's check this velocity. This velocity is 700. It was too much. And what was the size of this? It was 14. Okay, so I have to change this diameter to 14. Okay, so now we have a supply and return, and both go through the hallway. And that's key now. And before copying this, I know that there's going to be a conflict, okay? Because here we have the supply diffuser, here we have the return diffuser, and here we will have a supply and a return. And so that one, if this is the supply line, and this is the return line, here I'm going to have a conflict. So I want to fix that, to solve this conflict, and then I can copy the same solution different times instead of fixing the conflict 3 different or 4 or whatever. Okay, but there's going to be other conflict in this room, because here we have in this office we're going to have a supply and a return diffuser. So there will be something wrong with it as well. Let's do that. I'm going to copy this, copy a supply diffuser here. But now I have to change the airflow, because the airflow, there were 4 people times 20, it's 80 CFM. So let's click 80 CFM. Okay. And now we have to connect this to the supply. I'm going to copy this one too, copy the return diffuser, copy. They should be lined up. They are not. Why? Okay, here they are lined up. And this airflow is 80. We have the same supply and return airflow. And now I am going to go draw duct all the way here. And we don't have this elbow because eventually I'll have to go through the shaft. So I have this, there will be a T here. So if I connect these two, I have a T. And be careful, is this return? Yes, it is return, and it's connected to the return thing. If we look at, if we see the colors, blue with blue, red with red, okay? Be careful with that. But now here we need the supply line. If we draw that, we do this, and that's the conflict that we have to avoid. Okay, are we here? So we have connected supply and supply. If we see the colors, red is connected with red, blue is connected with blue, but here this can't happen. Okay, so we have can't happen. I don't know if we have a, if we click here, do we have, okay, so you see that the airflow is 0. Why? Because Revit knows that here something is happening, something that shouldn't happen, because we have this, okay? So how do we fix this? Let's look at the problem in the 3D view. We have to fix it. So what do you want? We can either place the, we can do this with the supply or with the return. So that's a decision that we have to make, and it's not a better or a worse decision, but we have to solve this conflict. Okay, so I'm going to use the return. I'm going to fix the return. So here we have to go down. So I'm going to move it on here. And I have to go down. How can I do it? I'm thinking, okay, so I don't know if it will work or not, but I'm thinking now. So we have this middle elevation. I'm going to make it 10, the middle elevation, and I'm going to create a duct this way. Okay. And now I go to the 3D view, I rotate this, and yeah, so 10 is more than enough. So I think if I make the middle elevation 11, with 11, you see that there's an intersection here, so this can't happen. So it has to be 10 feet and 6 inches. Okay, with 10 feet and 6 inches, it works. Does it work with 10 and 8? It works. Does it work with 10 and 10? Yeah, it works. Oof. I'm not sure, so let's make it with 10 and 9. Yeah, so now there's there's a tiny gap between return and this. So now that's my problem. If I go to this front elevation, that's my, yeah, this is what I have to fix. Okay, so I have to connect this to this, and then I have to connect this to that one. The best way to do it is through a flex duct, but I think this is too close, so I'm going to move it slightly here, and I'm going to click here, flex duct, and connect it here. Did it work? Yes. Okay. So let's try to do the same thing here. I don't know if it's going to. Okay, if I'm connecting these two through a flex duct, it doesn't work. because that's the problem with ducts. Okay, so if we have two things that are close to each other, if we have a duct here and another duct here, I can't force the flex duct to do something like that. So I have to move it here, and now the flex duct will work. So what is this minimum distance? It depends on the size of the duct. If it's small, this distance is shorter. If it's too big, then this distance has to be wider. So this doesn't work. I'm going to move this here. And now let's see if I can connect it with the flex duct. Uy, joder. Yep, I think we have this intersection. Revit didn't like it when I did it. So can I move it slightly? No. Or maybe I can push this a little farther. And now let's see if it works. ¿Qué cojo? No, ahora. Okay, so now it works well because I don't have the intersection here. So apparently I have fixed the issue. I have to make sure that the flow is working, but here the flow is 0. Why? Look at this. Because I'm working with the supply air, and I'm connecting supply to return. So we have to be very, very careful with this, okay? So change this to return, and now the airflow will work. We have 600, okay, so now it works. So there are a lot of things that we have to check in when we have colors. Yeah, now I think it's easier to understand that everything is blue. Okay. Is there an easier way to do that? No, that I know of. But at least now we have fixed this problem, and then we can copy this layout in all the classrooms. So we don't have to fix it every time. So we need to understand what the problem is and why are we doing this? Because I am thinking of this guy. Okay. So I want to make his life easier. You can say, okay, forget about it. He gets paid for this. He will solve all the conflicts. And yeah, but if he sees this layout first, he knows where the conflict is going to be, and he can plan his work accordingly. He's not making decisions. Making decisions when you are here at the top of a scaffold, thinking that you are tired and whatever, making decisions there, it's terrible. We can make decisions. We are here, we are warm, you are in front of your computer, you are having fun. So solving conflicts here, it's easier than solving conflicts here at the top of the scaffold. Yep.
I'm losing all my
Okay. Here I have connected the supply diffuser of the room, of the office space, to the supply diffuser, the supply duct that it's in the hallway. I'm going to do it again, okay? So keep working and I'll do it again. So first, we have the diffuser, the supply diffuser. I'm going to delete this. Okay, so this is what we had at the beginning. We have the supply diffuser here, and then we have to go underneath the return, and then we have to connect this to the supply main branch that it's there. So first, duct. The duct is here. It doesn't have to be that big, but we will find out. Draw flex duct, connect it here, select the duct, check the flow, it's 80, the same as the diffuser, and the speed is 74. 74 is too low, so I'm going to change the diameter to 8. If I change this diameter, the velocity is 200. 220 is acceptable according to this, because it has to be between 200 and 500. Okay. So the velocity is acceptable. So now I have to move this down. I'm going to copy this part of the duct. I'm going to copy it here. And we have this conflict on the 3D view. We see that we have this intersection. So I have to move this down. I have to change the elevation. I think 11 worked, 11 feet. Check that it works. There is a gap between this duct and that gap and that one. And now we can connect with a flex duct, this and this. Okay, so we have fixed that one. And now we have to connect this duct to this one. They are the different levels. So I'm going to create a flex duct here. The connection seems correct, but the direction of the T is not. So I delete the duct, I rotate the T, and now I draw a flex duct. It doesn't work, okay? So I have to make it shorter and try again, flex duct. And now it works. There you go. Okay, I'm copying. Once I'm done with this, I have copied this 3 times. And now I have to finish the ducts because this is not open anymore. Here I don't have a T. Here I will have the elbow. So if I have an elbow, I have to delete this one. And that's wonderful. Okay, that's amazing in Revit. That's another amazing feature. You see that I select a T. Okay, and here we have a minus sign. Click here. It becomes an elbow. Do it again. If you select a T, but that's the last branch that I have. So this can't be a T because we are losing air. So I select minus and I have an elbow. Amazing. And now I can connect this one all the way. I have to connect it to that T. So now this is closed. Okay, so we have the first diffuser. This is 300. The first duct, this has to be 300. Then the second duct has to be 600. And now this has to be 600. Good. And this has to be 680. It is 680 because I'm connecting the office space here. Okay, so you see that when we have closed this gap, we do have flow in the hallway. And now this one should be 680 plus 680, which is 1320. Well, it's 272, but anyway, so I did the math wrong. But yeah, now it works. It works. Does it work? This is 80. And this is 1100 and whatever. And this, oh no, this I'm looking at the, sorry. I'm looking at the velocity. So the flow, it's 280, and the flow here, it's 360. Okay, that's correct. But what's the velocity? The velocity is 1200. Okay, let's check the table again. Because in the main branch, the velocity should be below 1000. Okay, so even in the hallway, we will listen to too much noise. This velocity goes well because it's 600. Okay, but when we have another branch, probably we have to increase the size of this. So that's what I'm going to do. Instead of 14, I'm going to type 16. And now that velocity drops to 974. And that one, this velocity is way too big. It's 1900 and it has to be below. Okay, so probably this one, because I have connected, this is the last branch. So I have to make this, probably I have to make this 20. So with 20, this velocity is 900. So that's good. And I have this mess now. You see, because I have this duct, this is 16. I have this duct, it's 20. And well, this is not acceptable. So I'm going to do it again. Okay, so all these reductions, it's too much. Why do I have to reduct this, then a T, then another duct, then another T, then another reduction? So I'm going to delete all these. And let's go step by step. The first thing I need is, well, I can select this and that. Okay, now I can connect this. I have a T there, and now I can connect this, and I have another T here. It doesn't work because this connection is too close. So I'm going to extend it beyond that, and I'll have space for that T. There you go. Okay, so now this is cleaner. I don't have too many reductions. I only have a T, another T, and just this reduction from 20 to 16.
Isn't your airflow too much in between that reduction by T on the flex stuff? The next one up.
The velocity is 1400. Yeah, it's too much, but it's so.
But if you just delete all that T and stuff and draw your 20-inch duct and connect it to that T down there.
Yes, that's another option.
And you won't have all those connections.
You can do it, okay? But yeah, what I did, I connected the. Yeah, you did it. Okay, so that's fine. Yeah, it can be better. So I like your solution better than mine, but I won't do it again.
Okay.
What we have to make sure is that the airflow, it's 2040. Okay, so the airflow is working. But we are done with the supply or duct. We have to do the same with the return. The return stops here. Okay, so this is the last return branch that we have. So again, I select the T, I click minus, I have this elbow, and now I connect this to the T, and I have to check the velocity. The return, okay, so this velocity is 600, that's good. This one, it's 1200, too much. So I think this has to be 16. So I'm typing 16 here. And now I will have the same issues with the reduction there. Okay, so I'm going to make this 20. And I'm going to do it your way, Zach, to make you happy. So I'm going to delete all this, and I'm going to connect the big one and the small one here. And now I need to connect this here, a T will show up, and that here, and another T will show up, hopefully. Yep. There we go. The good news is that once we have done the first floor, I only have to copy that to the second floor. Okay, I'm not going to do everything. I want you to suffer a little bit, and you have to connect the last office space. Okay, so now we have to go this way and that way. And you need to connect a supply and a return diffuser on this big office. So you have to connect the supply and the return. I think it's quite easy, but I want you to do it on your own. Because I have other concerns that I want to solve before finishing. I don't know if I'll have time. So I want to connect the supply main branch to the vertical one. And that's gonna be a pain in the neck. So that's supply, and this vertical one was supply. Okay, so I have to connect this and that. And again, I have this return diffuser, so I can't go all the way from here to here because there's an intersection there. So I need to go down, and then I have to connect this here. So how can we do it? Okay, first and this is 20. Okay, so it can be smaller than 20. So I'm going to insert duct. The diameter is 20. And I want to go here and there. Okay, so on the 3D view, I'm looking at this from this position. So that's the supply. There's intersection now, so I have to move it down, make the elevation 10. Okay, so we can make it 10 and 2 inches. Yep, so there is no conflict. And now I have to connect this to this main vertical branch, and then I have to connect this to this one. So let's try. I think if I drag this, there will be an automatic connection to the vertical. Yes, it is. And since this is the first floor, I don't need a T, I just need an elbow. So select the T and do this. So that's the elbow. Okay. And now I only have to connect these two. Does it work if I create a flex? Okay, I'm going to do something better. I'm just going to drag this here, see what happens. Okay, something has happened. It's not big enough. It's not big enough because here I have that intersection, so I can't do this. Anyway, I delete these weird things, and I'm going to what do I do? These are too close to each other. Those are 20. Will a flex duct work? No, apparently it doesn't. You did it? Okay. With the flex ducts, yeah, I have this worry. Option. Well, sometimes we have to do things that wouldn't be acceptable, but if I what?
Kind of like the elevation that tends to be lower a little.
I don't get your question.
For like the, where the elbow is, like that 10'2", we lower that. We can, yes.
Yeah, whatever works. I mean, there are different options here. I'm doing something because I'm tired and I'm reducing the size of this flex duct to 12. And even with 12, it has this. Okay, but I think I have good. No, I don't have good news. Maybe I can reduce this one a little. It's 20. I'm going to make it 18. Okay, I think now it's working well. And if I make this 16, for sure it will work. Where is this diameter? Okay, so that's it. There will be points in which we have to do something weird. So we can't have the perfect flow, the perfect velocity. But if those elements happen close to the shaft, it's not a big concern because nobody's living there. Okay, so even if you walk on the hallway and you listen to, it's not a big deal. Okay, so at least make sure that in the classroom everything works well, and then there will be a point in which we will have these conflicts. But 16. Yeah, so that works.